In this problem, we are going to transform the square root function. It's going to be easiest if we identify some anchor points to hang on to and track as we go through this process. So I am selecting to choose and follow 0, 0 here. That is the main anchor point. Square root function is a little bit unique in that it starts at the origin and then just springs off to the right here due to the domain restrictions of not being able to take square roots of negative numbers in the real numbers. So 1, 1 and 4, 2 are also nice integer points that we could track. And I would kind of point out the fact that if you know where this original anchor point at the origin is, you can take steps, right 1, up 1, or right 4, up 2, and get to these other anchor points on the parent function. As we transform it down here, we're going to see that change. So a couple things. We do have a shift right 2 units. That's that inside layer affecting that. Then we have a shift down 6. Say 2 there. And the 4 being multiplied on the outside layer, that's going to be a vertical stretch. Stretch, since the scale factor is larger than 1, by 4. So for vertical stretches and shrinks, remember that the scale factor is the multiplier. We look at the reciprocal of the multiplier when we are dealing with horizontal stretches and shrinks. Okay, so what we're going to do here is move that anchor point I mentioned at the origin according to this shift right 2 and down 6. And let's do that here. Right 2 and down 6 would put it right there. So that is kind of our new epicenter origin, so to speak. Now, if there was no vertical stretch whatsoever, I could simply find the rest of the points by going right 1, up 1, just like I did with the pattern on the first graph, and right 4, up 2 would get me the other point, and that would be the transformed function. However, we don't have it that simple this time. Instead of going right 1, up 1, and right 4, up 2, we have to multiply those ups by 4. Okay? That's where that 4 is going to come in. So instead of going up 1, I'm going to go up 4, and that's going to put us up to a height here at the -2 level. And instead of going up 2, when we go right 4, 4 times 2 is 8, so 8 above -6 will be all the way up here at +2. So we end up with a transform graph that is quite a bit steeper. If I had to freehand it there, that's about as good as I've ever done. Something that looks like that. So on the multiple choice below, we are looking for that likeness, and you can rule out a lot of these pretty quick. Let's look closer at option A here. I see the anchor point in the correct position there at 2, -6. So that makes me interested. I also see it traveling through approximately that point at 3, -2. And I also see it traveling neatly through 6, 2. So I'm able to confirm all the points I tracked. And let's see here. Yeah, none of the other ones come close. That anchor point's wrong on B. We have the original anchor point wrong on D. And even though C has the correct first point, you could see it is stretched way out of shape. It's way up here at 6, 10, which is much too big of a stretch. So that would be incorrect. So we will select A for this one. I hope that made sense.